Right now, as you read this, a version of you is dying. Another is falling in love. Another never existed at all. The equations of modern physics do not just allow this, they demand it. And the deeper scientists look into the fabric of reality, the more they realize something terrifying. The universe is not solid, not stable, and not even entirely real. So what exactly are we living inside of? Every assumption you have about time, space, matter, and self has already been falsified by experiment. These are not theories. These are measured results. And what they reveal is genuinely disturbing. Number 10. The paradox of Schrödinger's cat. A cat sealed inside a box is simultaneously alive and dead until someone opens the lid. This is not a metaphor. In 1935, Austrian physicist Erwin Schrödinger designed this thought experiment to expose what he believed was an absurdity in quantum mechanics. A radioactive atom with a 50% chance of decaying within an hour is linked to a vial of poison. According to the Copenhagen interpretation formalized by Niels Bohr and Werner Heisenberg, the atom exists in a superposition of decayed and not decayed until observed. The cat, by extension, exists in a superposition of dead and alive. In 2010, physicists at the University of California, Santa Barbara, scaled this effect up, placing a visible metal strip into a superposition of vibrating and not vibrating at the same time. The implication is staggering. Reality does not appear to commit to a single state until a measurement forces it to. The world you see is not the world that exists when you look away. Something about consciousness or observation or the very act of asking a question seems to collapse possibility into fact. And if that is true, then what is the universe doing when no one is watching it? The answer is even stranger than the question. Number 9. The double-slit observer effect. Particles behave differently when they know they are being watched. In the original 1801 experiment by Thomas Young, light passed through two narrow slits and produced an interference pattern, behaving as a wave. But when modern physicists fired individual electrons, one at a time, through the same setup, those single particles still produced an interference pattern, as if each electron passed through both slits simultaneously. Then came the disturbing part. When detectors were placed at the slits to record which path each electron took, the interference pattern vanished. The electrons began behaving like solid particles. This has been replicated thousands of times, including a landmark 1998 experiment at the Weizmann Institute of Science in Israel, which proved that the mere presence of a measurement device, not human awareness, was enough to change the outcome. Think about what this means. Information itself appears to shape physical reality. The universe behaves one way when unmeasured and another way when it is. There is no classical explanation. There is no mechanical trick. The act of gaining knowledge about a particle physically alters what that particle becomes. So if reality reshapes itself under observation, what does it look like when nothing is observing it at all? Number 8. The grandfather paradox. General relativity allows time travel into the past, and this is not science fiction. In 1949, mathematician Kurt Gödel, working alongside Albert Einstein at Princeton, solved Einstein's field equations and discovered a valid solution describing a rotating universe that contains closed timelike curves, paths through spacetime that loop back to their own origin. Stephen Hawking spent decades trying to disprove these solutions and failed. Now imagine traveling back along such a curve and preventing your grandfather from meeting your grandmother. You would never be born, which means you could never travel back, which means your grandfather would meet your grandmother, which means you would be born. The logic eats itself. Physicists like Igor Novikov have proposed a self-consistency principle, arguing that the universe forbids paradoxes by forcing any time traveler to fail at altering the past. But that solution itself implies something terrifying. Free will may not exist in any meaningful sense. Every choice you have ever made may already be locked into the fabric of space-time, predetermined to remain consistent. The past, the present, and the future may all exist simultaneously, frozen and unchangeable. And if that is true, then time itself is not what you think it is. But the next paradox suggests time may not exist at all. Number 7. The block universe and the death of now. There is no such thing as now. Einstein's special relativity, published in 1905, mathematically proved that simultaneity is relative. Two events that appear simultaneous to one observer can appear separated in time to another, depending entirely on their motion. This led physicists, including Hermann Minkowski, to consider the possibility of a unified field theory, to formulate the block universe theory in which past, present, and future all exist together as a single, unchanging four-dimensional structure. Time does not flow. It is. In a 1955 letter mourning his lifelong friend Michel Besso, Einstein wrote that the distinction between past, present, and future is only a stubbornly persistent illusion. Modern experiments, including atomic clock comparisons aboard GPS satellites, confirm that time dilates by measurable amounts, up to 38 microseconds per day. The implication crushes every intuition you have. Your birth, your death, and every moment in between already exists somewhere in spacetime. You are not moving through time. Your consciousness is simply illuminating one frame after another along a path that has always been there. So if every moment of your life already exists, frozen in place, then what exactly is the thing inside you that experiences them in sequence? Hold that question. The next paradox will make it worse. Number 6. Quantum entanglement and spooky action. Two particles separated by the entire universe can influence each other instantly. In 1935, Einstein, Boris Podolsky, and Nathan Rosen published the EPR paradox to demonstrate what they thought was a flaw in quantum mechanics. Their argument was simple. If measuring one particle could affect another instantaneously across any distance, that would violate the cosmic speed limit set by relativity. Einstein dismissed it as spooky action at a distance. But in 2015, physicists at Delft University of Technology in the Netherlands performed a loophole-free Bell test using entangled electrons separated by 1.3 kilometers and confirmed that the correlation is real, instantaneous, and not explainable by any local hidden variable. In 2022, the Nobel Prize in Physics went to Alain Aspect, John Clauser, and Anton Zeilinger for proving this beyond any reasonable doubt. The implications are crushing. Either information travels faster than light, which breaks relativity, or the universe is fundamentally non-local, meaning distance itself is an illusion at the deepest level. Two particles, no matter how far apart, may not actually be two separate things. They may be one object expressed in two locations. Which raises a question physicists are only beginning to confront. What if space itself is not real? Because the next paradox suggests it may not be. Number 5. The holographic principle. Everything you see, touch, and experience may be a two-dimensional projection. In the 1990s, physicists Gerard T. Hooft and Leonard Susskind proposed the holographic principle, building on Stephen Hawking and Jacob B. Kinstein's earlier work on black hole entropy. Their math showed something nobody expected. The total information contained within any region of space is proportional not to its volume, but to the surface area of its boundary. This means a three-dimensional universe can be perfectly described by data encoded on a two-dimensional surface, the way a hologram encodes a 3D image on a flat film. In 2017, a team at the University of Southampton tested predictions of holographic cosmology against the cosmic microwave background and found the model matched observations with remarkable accuracy. Take a moment with that. The reality you walk through, the body you inhabit, the depth of the room around you may all be a projection emerging from a flat sheet of information at the edge of the cosmos. You are not made of matter in the way you imagined. You are made of data. And if reality is information, then someone or something is processing it. Which leads directly to a paradox that has paralyzed physicists for nearly 50 years. Number 4. The black hole information paradox. Information cannot be destroyed, but black holes destroy it. In 1974, Stephen Hawking proved that black holes slowly evaporate by emitting what is now called Hawking radiation, a faint thermal glow caused by quantum effects near the event horizon. The problem is that this radiation appears completely random, carrying no memory of what fell into the black hole. So when a black hole finishes evaporating, all the information about every star, every planet, every conscious being it consumed should be permanently erased. Quantum mechanics absolutely forbids this. The unitarity principle states that information must always be preserved. In 2019, physicists Jeffrey Pennington, Ahmed Almeri, Netta Engelhardt, and Don Meroff published calculations suggesting information does escape, but through a mechanism so strange it appears to require wormholes connecting the interior of the black hole to its outgoing radiation. The implication shakes the foundations of physics. Either Einstein's general relativity is wrong, or quantum mechanics is wrong, or reality has hidden connections between things we believed were separate. One of the most successful theories in human history must be broken, and that crack in the foundation hints at something deeper, because the next paradox suggests the universe should not exist at all. Number 3. The cosmological constant problem. The universe should have ripped itself apart at birth, or collapsed instantly into nothing. When quantum field theory calculates the energy of empty space, the vacuum energy that fills every cubic centimeter of the cosmos, it predicts a value approximately 10 to the power of 120 times larger than what astronomers actually measure. That is a 1 followed by 120 zeros. Physicist Steven Weinberg called it the worst theoretical prediction in the history of physics. The measured value, confirmed by observations of distant supernova by Saul Perlmutter, Brian Schmidt, and Adam Rees in 1998, and rewarded with the 2011 Nobel Prize, is almost zero. But not quite. It is just large enough to cause the universe to expand at an accelerating rate. If it were slightly larger, galaxies could never have formed. If it were slightly smaller or negative, the cosmos would have collapsed long ago. The fine-tuning is so absurd that some physicists, including Martin Rees and Max Tegmark, argue that the only sane explanation is a multiverse. Countless universes must exist, each with different constants, and we live in one of the rare ones that allows life. Which means we are not the universe. We are a survivor of an infinite lottery, and the next paradox suggests we may not be alone in being copied. Number 2, the many worlds interpretation. Every decision you have ever made has also been made the opposite way, by another version of you in another world. In 1957, Princeton physicist Hugh Everett III proposed that the wave function of quantum mechanics never collapses. Instead, every possible outcome of every quantum event actually happens, each in its own branching universe. For decades, it was dismissed as bizarre, but in recent years many leading physicists, including David Deutsch, Sean Carroll, and Max Tegmark, have argued it is the most mathematically clean interpretation we have. There are no extra postulates. There is no mysterious collapse. There is only the wave function branching endlessly. Consider what that means in practice. Every time a single atom in your body decays or does not decay, the universe splits. Every breath, every glance, every word generates a near-infinite cascade of parallel realities. Somewhere, you took the other job. Somewhere, you said yes. Somewhere, your loved ones never died. Somewhere, you never existed at all. In 2014, researchers at Griffith University in Australia developed the Many Interacting Worlds model, suggesting these parallel realities may even leak measurable effects into our own. You are not one person living one life. You are an uncountable number of selves spread across an uncountable number of worlds. And yet, even that is not the most disturbing thing physics has revealed, because there is one paradox that breaks everything. Number 1, the simulation paradox and the observer at the end of reality. You may not be a human being. You may be a thought inside something else. In 2003, Oxford philosopher Nick Bostrom published his simulation argument, demonstrating that if any advanced civilization in the history of the universe ever creates high-fidelity ancestor simulations, then almost certainly the beings inside those simulations would vastly outnumber biological beings. By simple statistics, you are more likely to be one of the simulated minds than one of the rare originals. This is not a fringe idea. Neil deGrasse Tyson has called the odds better than 50-50. Elon Musk has stated the chance we are in base reality is 1 in billions. And, in 2017, physicists at the University of Oxford, including Zohar Ringel and Dmitry Kovrizhin, demonstrated mathematically that simulating certain quantum systems would require computational resources growing exponentially with the number of particles, suggesting either we are not in a simulation or the simulation is using physics we do not yet understand to economize. But here is what makes this entry the heaviest of all. Every previous paradox on this list, the observer effect, the block universe, the holographic principle, the fine-tuned constants, the branching worlds, points in exactly the same direction. Reality behaves like information. Reality responds to observation. Reality is rendered, not built. And if all of that is true, then the deepest question is no longer whether the universe is real. The deepest question is who or what is watching it through your eyes right now. What you call solid ground, what you call your body, what you call the present moment, none of it survives close inspection. Physics has spent 100 years quietly dismantling the world we thought we lived in, and the wreckage is staggering. Particles that know they are being watched, time that does not flow, information that cannot die, universes that may not be ours. Somewhere beneath the equations, beneath the experiments, beneath every safe assumption, something is looking back at us. And the most unsettling possibility of all is that it shares your face. If you want to see more videos like this, click the video on screen now.